Lesson number 33 is about products of prime numbers and statements about unusual quantities, and we'll figure out what that means after we go through products of prime factors. Our first problem is to express 80 as a product of prime factors. So we want to figure out which prime numbers we can multiply together in order to get a product of 80. In order to do that, we can use a factor tree. So let's take 80. What we're going to do is we're going to break 80 down into prime factors. In order to do that, we're going to have to figure out factors of 80. Well, I know 10 times 8 is 80. Okay? And then we can break 10 down. We can break 10 down into 5 times 2. We've got two of our prime factors that give us 80. Let's go ahead and circle those when we're at the bottom of our factor tree. 8. 8 is made up of 4 and 2. There's one more prime factor, 2. And 4 is made up of 2 times 2. So we've got our other prime factors. In order to express 80 as a product of prime factors, we're going to get 2 times 2 times 2 times 2 times 5. And a simple way to write that will be 2 to the 4th power times 5. And we're all done, because we know that this is equal to 80. So we've expressed 80 as a product of prime factors. We can go ahead, all we have to circle is this part, 2 to the 4th times 5. We don't need to say it equals 80 because we know it does. Now just as a note, you could have broken this problem down into 40 times 2, or you could have broken it down into 5 times 16. There's many different ways that you can start these problems, but you'll always end up with the same prime factors in the end. Let's go ahead and move on to our next question. 5 times a number is 72 greater than the opposite of a number. Find the number. This is the type of problem that we have unusual quantities. And when we have this, well, all we're going to do is we're going to take this statement and we're going to put it into an algebraic equation. So 5 times a number, that's 5 times n. 5 times a number is, so that's equal to, 72 greater, so we're going to be adding, than the opposite of a number. So the opposite of a number is going to be negative n, because we're taking the opposite of that number. And then it's 72 greater than that. So we're going to add 72. Now from here we can go ahead and we can figure out what our answer is. We need to find out what n is equal to in order to make this equation true. So I'm going to add n to both sides, because I want to move the n's over to the left. So we add n to both sides, and we're going to get 5n plus n, well that must be 6n, is equal to negative n plus n is 0, plus 72. So 6n is equal to 72. Now we have to figure out what number we need to multiply 6 by in order to get to 72. When we figure that out, that will tell us what n is. One way to do that, well, we want to undo the multiplication of 6 times n. To undo multiplication, we divide. We're going to divide by 6 on both sides, and we get 72 divided by 6. When we can figure out 72 divided by 6, we have our answer. What is 72 divided by 6? Hopefully you said 12, because 12 times 6 is equal to 72. So we've got our final answer. N must be 12. Let's move on to our next example. Here we have 5 times a number is 21 less than twice the opposite of the number. What is the number? We're going to go through the same process we did in our last example. 5 times the number, that's 5n. Is, so equal to, 5 times the number is 21 less, so we're going to be subtracting 21 from something, then twice the opposite of the number. So twice the opposite of a number must be 2 times negative n. Twice the opposite of a number. And remember, it's 21 less than that, so minus 21. Now we can go ahead and solve that. We've got our equation written out. Let's rewrite. We're going to have 5n is equal to, we're going to make this easier to read. We're going to say negative 2 times n, because order of multiplication doesn't matter. The negative sign can be on either of the numbers, minus 21. So now, what we know we have to bring the n's over to the left-hand side. So we're going to add 2n. We're going to add 2n to the left-hand side to balance out our equation. 5n plus 2n, that gives us 7n. Negative 2n plus 2n is 0, and then we have minus 21. This one, 7 times some number n is equal to negative 21. What's our value of n? N must be equal to negative 3, because 7 times negative 3 is equal to negative 21, and we figured out our answer. We'll practice this some more with our lesson practice, page 136. Make sure you've got your notes complete, and I'll see you during our next class.